All right, excuse me, final exam review for 92. And we're going to remember on the final, you're going to have to show all your work to get any credit for your solution, whether it's right or not. You have to put work that makes sense and that someone can follow to follow your thinking. So we want to make sure on the review we are practicing showing our work as well. And let's see, number one's got a little bit of everything. If it gives a method to solve your quadratic equations, you have to use the method it asks for, even though there's 4 different methods. So follow directions. And this one says, excuse me, solve the quadratic by finding by using the square root method, but then it says complete the square first. So let's do that. So looking at our quadratic here, I know it's a quadratic because it has one of the variables squared or raised to the second power. The problem with it is it also has a number over here. It's supposed to be 0 over there for us to use any of the methods. So the first thing we need to do is fold that back in by adding its opposite. So that's going to be a 0. Okay? That's what you need to do for all of the methods for solving a quadratic. All right, that gets us there. So specifically to complete the square, we need to get rid of this 4 that's in front, whether it goes evenly to everything or not. To me, that's an odd step, but because usually we're taking out a greatest common factor. When completing the square, the only way it's going to work is to remove any numerical coefficients other than 1 in front of your variable squared in your first term there, okay? Because I need that to be a 1 there for this to work. So this is going to turn into a 3a, and this is going to stay, I don't want to turn into a decimal. That's going to stay what it is. So my c term is a fraction. That's okay, it's going to work out. All right, and the way I like to do these is put a plus, and then whatever b is, including the sign, you're putting over 2 and square. And then I have moved this fraction by adding its opposite to the other side. And whatever we add to one side, we're adding to the other side. Okay. And then I like to go here and write the a, and then what's in this parenthesis here is a -3/2 squared. So that's how I do those. But it doesn't excuse me for figuring out what that all equals. So this is going to be a -3/2 times a -3/2, which is going to give me a 9/4. So this is going to be 91/4 plus 9/4. That's going to give me 100/4. And then we are going to square root both sides. So you get a minus 3/2 equals plus or minus the square root of 100/4. And then you're going to add 3/2 to both sides. All right, to move that over. So let me get rid of this to get a little more room here. All right, so I'm going to be left with a equals a positive 3/2 plus or minus the square root of 100 over the square root of 4. I can split that up like that because that's going to be 3/2 plus 10/2 is 13/2, and it's also going to be 3/2 minus 10/2, which is -7/2. And then it says write my solution with a comma between them, so a is going to equal -7/2 13/2 for that one. Okay. Number 2, got a quadratic also, and it just says solve. So let's think through the methods here. I always check if my quadratics will factor first, especially if there's no numerical coefficient. That would be easy if it would, but 31 is prime, so I'm thinking it's not going to. So I believe I'm going to go right to the quadratic formula. So my A is 1, my B is 5, my C is 31. Okay, so T is going to equal opposite B, square root of 5 squared minus 4 times A times 31. It's probably a good idea at the top of your page to write down all the formulas that you need until you make sure you memorize them all. Hopefully you can read that. There's my quadratic formula. 2 times A. All right, so this is going to be T equals negative 5 plus or minus negative 99 over 2. Now, negative 99, that's a negative radical, so we need to take that out as an I. And biggest square root in there is a 9, which is a 3, and then what's left is an 11. So T is going to equal negative 5 plus 3i square root of 11 over 2, and negative 5 minus 3i square root of 11 over 2. Another way to write that, check with your instructor. Remember, all of these can be split up. Just be really careful to get all your signs right. All right, that's another way to write them. Okay. Number 3, solve. And it's already set up for you in the square root method. Even root property being followed here. So here, let me write it over here. When it's already set up for a square for you, what you need to do, if it's raised to the power of 2, you want to square root it. And that'll take everything off this side. And because it's an even power, you need to add the plus or minus. And the square root of 25 is 5. And then you need to move the 2 over. So remember, this 2 can't be put with the 5. It's in front of it because orders of operations says it has to be that way. Okay, so this is going to be x equals 2 plus 5, and x equals 2 minus 5. And let's see, if it's in this weird form, think of a number line. The negatives are down to the left, so that's the smaller, and then the 7 will be up there. If you need to put a comma between it, that's a recommended order, right? All right, the next one says, kind of odd looking, it says solve for x. So, well, I like to clear my denominator then. It's an equation. It's got an equal sign. So since it's an equation, I know that I'm allowed to clear my fraction by multiplying by whatever is in the denominator. Whatever I do to one side, I do the other side. Excuse me. All right, so this makes this a little more regular looking. Oops. All right, which means this can be FOILed. This will have to be, if I don't have an equal 0 on the left-hand side here on the other side by itself, that means all of this needs to be FOILed, put back together. Then that 9 needs to be brought over, and then we'll look at the quadratic we have after we do that. All right, so let's FOIL. Excuse me. So 3x times 3x, here, just put this here, is 9x squared, and then we have 9x plus 9x, which is a positive 18x, and then 3 times 3 is 9. All right, this has got a lot of 9s. Stick to the rules here, get all the terms on one side. It's got a quadratic. All the terms must go to one side. If it was linear, you would get to keep x's on one side and constant terms on the other, but since it's a quadratic, everything has to go to one side and then determine the method to solve. Oh, and my c term goes away. Excuse me. So that means I got a little more options here. What I can do is pull out a greatest common factor and then use the 0 property that says I need to set all my factors equal to 0 and solve. So this was a little strange, but remember, we need to be ready to do some critical thinking with the rules that we've learned through the whole semester. So if I need to put them in order with the lowest one first, that would be that way. Okay. All right, an object is dropped from the height of 160 feet. Here's the equation, the quadratic over here. Let me, it's not in proper order. Let me rewrite that. I need the x squared term to be first, and notice that it's negative. Be careful with see how the paper, it's kind of split up here. So make sure this negative right here goes with that term, and that's a positive 160. Which is also strange because you're missing your B instead of your C. So once you put it in the right order, your A is 16, your B must be 0, and your C is 160. It said it will start at a height, it's dropped from 160 feet. That's always, the start is always C, so that sort of confirms that B is not there. Okay, that's okay. Just follow all the rules anyway. Then it gives you a little clue here that I need to round to 2 decimals, so it's not going to be even numbers in here. All right, let's see. What is it going to ask? It's really important to read. A lot of these questions have 2 questions, but these don't look like your typical questions. What is the height of the object after this? So they're telling you that the height is 1.3. So if the height is 1... Oh, wait. Here, I gotta read. It's very important to read. What is the height after this? So they're saying t is 1.3. Okay, so we need the height of 1.3, where it is when it, okay, it says it's dropped, right? It says, where is it after 1.3 seconds? That means we're looking for a y, or the h of t, for 1.3. So when x is 1, or t is 1.3, what is h? So negative 16, 1.3 squared plus 160. And remember, orders of operations says find the square first, then multiply by negative 16, and you should get 132.96 feet. Right? We want a height in feet. How long will it take to get to the ground? How long it will take to get to the ground when the height is 0. Okay, so when the height's 0, what is t? So that's a quadratic. I could take a greatest common factor out and make my numbers smaller. I just don't. There's just you're going to get the same answer, and you're not going to get any points off for not doing that first. So I just go with it whether it comes out or not. So I just follow all the rules here. A equals negative 16. B, we wrote it down up there, equals 0, and C equals 160. So that means in my quadratic, t is going to equal 0 plus or minus the square root of 0 squared minus 4 times negative 16 times 160. All right. So put all that in my calculator. The discriminant is going to come out to be a positive number. That plus and minus belongs to that radical, not to the 0. So the plus or minus must stay there. And you get this number as a radicand. Okay. So plus or positive, find that answer and then divide by 32, and you're going to get a negative 101.19, which doesn't make sense when you're talking seconds. So that's not the one I want. So I must want the negative 10240 over negative 32. That's going to give me 3.16 seconds. That's the one I want. Okay, that's how long it's going to take to get to the ground. Remember, this is a one-sided drop here. So notice I didn't put the other side of the parabola in. We're not concerned about this negative number over here on the x-axis. We just want the positive one when it gets to the ground on this side, which is apparently 3.16 and 0. Okay? And then the last one, here's another quadratic. It has two solutions. Put them in the order. And it doesn't really say anything else about it. I don't know. I spend about 5 seconds looking at it to see if it's going to factor, and some people, maybe better at factoring than I am, but if it doesn't come instantly to me, I always go to the quadratic formula because it'll always work. My clue right here that it's not going to factor is the fact that it says 3 decimal places or exact radical. Okay, so that means it's not going to factor. So I just go right to the quadratic formula. So A is 1, B is 5, and C is a negative 20. Put that sign in there. So this is going to be x equals negative 5 plus or minus square root of 5 squared minus A times 1. Get that negative 20 in there. And then I always find my entire discriminant at once. Square the 5, you get 25. I got 2 negatives, so it's going to be a positive result. 25 minus a negative, and then that should come out to 105 over 2. So x equals negative 5 plus 105. 105, have any... What's in a 105, just to see if it says or exact, so maybe it wants a reduced radical. 105 divided by 5 is 21. 21 is a 3 and a 7, so there's a 5, 3, and a 7, so there's no perfect squares in a 105. So put that in your calculator. That should get 2 like that. Get my 3 decimals, okay, and then negative 5 minus 105 over 2. That's going to be negative 7.623. Since it's an abstract problem, it wants both of the answers. Okay, which one's the lower answer? The smaller answer, it says that's what this means. So this was going to be the negative 7.623, and this one's going to be the positive number. Okay.